Welcome to this video on solving radical equations. So this video I'm just going to cover two examples with a brief explanation on the second example of why we do something the way we do it. So first we have the radical equation y plus 2 times the square root of 4y minus 3 is equal to 3. Now this looks a little ugly, yes. Solving radicals can be tricky, but solving linear or quadratic equations is fairly simple. It's something we're used to. So can we make this look linear or quadratic? And sure, we can try and get rid of that radical by squaring both sides, but here's the problem. If I square this left-hand side, I'm not actually going to get rid of the radical as is. So I'm going to start by isolating the radical term. I'll do that by subtracting y from each side. And we get 2 times the square root of 4y minus 3 is equal to 3 minus y. Now this time, if I square both sides, we will get rid of the radical. So I go ahead and square the left-hand side, square the right-hand side. Well, exponents do distribute over multiplication, so this is just 2 squared, which is 4, times the square root of this squared, which is just this. On the right-hand side, we have to remember that we're squaring a binomial. It has 2 terms, so we don't just get 3 squared minus y squared. We get 3 squared, 3 times negative y, so minus 3y, another 3 times negative y, which is minus 3y, and plus y squared. So just combine like terms and distribute that 4. We have 16y minus 12 is equal to 3 minus 6y plus y squared. Okay, this is quadratic, so we want it set equal to 0. I'm going to do that by subtracting 16y and adding 12 to both sides. So we have a 0 here. I'm also going to rewrite the order of terms while I'm at it because we like to have the y squared up front. Negative 6y minus 16y is negative 22y. And 3 minus a negative 12, so plus 12, is plus 15. And so we need to come up, oops, what did I do wrong? I didn't square the 3. This should be a 9. And so 9 plus 12 is 21. That's going to make things work out better. And how do we solve a quadratic? We factor it. So we have 0 is equal to, I need two things that multiply to 21 and add to 22. Well, 21 and 1 sounds good to me. So y minus 21 times y minus 1. And double check, that's y times y is y squared. Negative y minus 21y is 22y, negative 22y. And negative 21 times negative 1 is positive 21. So in theory, this tells me y equals 21 and y equals 1. But here's a problem. We squared this radical. Now imagine that all we had in here was a 4. Imagine this y minus 3 wasn't here. Well, the square root of 4 is positive 2. And then 2 squared is 4. That makes sense. But the problem is if I just have x squared equals 4, that has 2 solutions. X could be either positive or negative 2. So when I've squared things, I might have introduced false solutions. So I need to check them. Every time I'm playing with a radical equation, I'm going to have to check my answers. Let's first look at x equals 20, or sorry, x. What on earth am I talking about? Y equals 21. Well, if I plug that into the original equation, I have 21. So the original equation right over here. plus 2 times the square root of 4 times 21 plus 3, and ask, is that equal to 3? Well, that's 21 plus 2 times the square root. 4 times 21 is 84, right? Why is that a plus 3? That should be a minus 3. There we go. 84 minus 3. Is that equal to 3? 84 minus 3 is 81. And the square root of 81 is 9. So we have 21 plus 2 times 9 is 18. And ask, is that equal to 3? At this point, we can clearly see it's not. So 21 is not one of our solutions. Okay, how about y equals 1? Well, that means we've got 1 plus 2 times the square root of 4 times 1 minus 3. We're asking, is this equal to 3? Well, let's do this sort of quickly. 4 times 1 is 4, minus 3 is 1. So we have 1 plus 2 times the square root of 1. And ask, is that equal to 3? And square root of 1 is 1, times 2 is 2, plus 1 is 3. That is good. So this is a valid solution. Okay, what if the equation has 2 radicals in it? What if instead we have the equation square root of 3m plus 1 minus the square root of m plus 4 equals 1. And now, like in the last case, it's tempting to just say, let's just square everything that I see. But the question, is the square root of 3m plus 1 minus the square root of m plus 4 squared equal to square root of 3m plus 1 squared minus the square root of m plus 4 squared? Is that true? Well, if it's true, it has to be true for all values of m, so let's pick a convenient one. We'll let m equal 0. I don't know if m equals 0 works for this equation over here. I'm not even looking at that. But we'll try it here. Because if I can just square both of these terms, like what I'm doing here, then whenever m is 0, these should be the same. These should be the same for any value of m. So if m is 0, on the left-hand side, we have the square root. 3 times 0 is 0, plus 1 is 1. Minus the square root of 0 plus 4 is 4. And we're squaring that. On the right, we have the square root of 1 squared minus the square root of 4 squared. So again, let's look at this left. Square root of 1 is 1. Square root of 4 is 2. So we have 1 minus 2 squared. On the right, square root of 1 is 1, but we're squaring that. Square root of 4 is 2, and we're squaring that. 1 minus 2 is negative 1. Negative 1, so we've got negative 1 squared over here. 1 squared is 1, 2 squared is 4. So on the left, we have negative 1 squared, which is just positive 1. On the right, we have negative 3. Those are not equal, so this operation that we did up here is invalid. What we're going to have to do is isolate a radical. Which one? Since I'm subtracting this one, I'm just going to add it to the other side, make things easy. So we have the square root of 3m plus 1 is equal to square root of m plus 4 plus 1. And now we can square both sides. Left-hand side is easy to square. That's 3m plus 1. Right-hand side is a bit trickier. Remember, I can't just say m plus 4 plus 1 squared. Doesn't work. I'm squaring this, so I need the first term squared, which is m plus 4. I need 2 times the first times the second, which means 2 times the square root of m plus 4. Uh-oh, I've not gotten rid of all of my radicals. That'll be a problem in a few minutes. We can wait for now. Now I need the last term squared, which is 1. So now I still have a radical equation. So I'm going to have to go back and basically do what I did during that first one. I'm going to isolate the radical, which means, well, the radical term, which means I'm going to subtract the m, subtract the 4, and subtract the 1. Luckily, that's not too hard. I subtract the m, I've got 2m. I subtract 1 from both sides, that goes away. So I just have to subtract the 4. 2m minus 4 is equal to 2 times the square root of m plus 4. Now last time I would have squared both sides at this point, but I notice there's a 2 here, there's a 2 here, that's 2 times 2, and there's a 2 here. So if I divide everything by 2, I get m minus 2 is equal to the square root of m plus 4, and that'll be just a little easier. Now I can square both sides, and that is m squared minus 4m plus 4 is equal to m plus 4. This is a quadratic. I subtract everything over. M squared minus 5m. 4 minus 4 is 0, so we're left with that, and that factors nicely. So we have m equals 0 or m equals 5. Let's test them. Oh, what was my original? 0. We'll plug a 0 in. So the original was 3 times 0 plus 1 minus the square root of 0 plus 4 is equal to 1. Well, 3 times 0 is 0 plus 1 is 1, so that's the square root of 1. 0 plus 4 is 4, that's the square root of 4 is equal to 1. And we get 1 minus 2 equals 1. Sorry, I forgot my question marks. That is not true, so 0 doesn't work. Now, just because 0 failed does not mean 5 is my answer. It is possible that we have no solutions, so we have to check 5 independently. So we have the square root of 3 times 5 plus 1 minus the square root of 5 plus 4. We're asking, is that equal to 1? 3 times 5 is 15, plus 1 is 16. 5 plus 4 is 9. Square root of 16 is 4. Square root of 9 is 3. That does, in fact, equal 1. So m equals 5 is a solution. I hope this video helps out a bit.